Alright, this is unit number 2. We are on page 4. We're doing sign conventions for displacement, and the concepts that we're going to pick up in this video are going to be used the rest of this year. So this is a pretty important one for you to get. And here's example number 4. It says a number line and an equation use the number line and an equation. And here's the equation for displacement. To calculate the magnitude of each example, then identify the direction of the movement. So we're gonna we'll go ahead and do the equation first, and then in the number line, and then we'll kind of move from there. So we'll start with the number line and see what we can come up with. So let me zoom this in just a little bit. There we are. All right, so we're going to start at the 5th meter and go to the 8th meter. So if we were to have a number line here, and this were the 5th meter, and this were the 8th meter, we're going to move in this direction. So what do they want up here? They want the magnitude of each example, then write the direction of the motion. So magnitude would be how big, and so how big is going to be simply how far do we travel? We traveled 3 meters, and which way did we move? We moved to right. I think I'm going to go ahead and run through and do the number line first for each example, then we'll come back through and use the equation. All right, the second one, we're going to be at the 8th and we're going to the 5th. So here's the 8th meter, and there's the 5th meter. Almost looks like a -5 there. And so if we go to the 8th, the 5th, we're moving in that direction, so that's going to be to the left. So I'm going to go 3 meters to the left. Okay, the next one, an object moves from the 3rd meter to the origin. Or, I'm sorry, from the -3rd meter to the origin. So -3 meters sits over here. 0 meters from here. We're going to start here and go here. So we're moving to the right, and we went 3 meters to the right. The next one, we're going to start at the -3rd meter and move to the, no, I'm reading the wrong one here. All right, the 8th meter and go to the -6th meter. All right, so 8 is going to be out here. Here's 0, and here's -6. So if we're starting at the 8 and going to the 6, that's going to be a total of 14 meters, and we're going to the left. So we'll say 14 meters and to the left. Here's the next one. We're looking for a trend here eventually. And hopefully you'll start to see it as we approach the end of this example. Alright, so -3 to -1. So here's -3 to -1. That's 2 meters. So we'll come over here. 2 meters, and we move to the right. And here's our last one, number 6. So the object moves from -4 to -7. So here's -7. There's -4. So we're going -4 to -7. So that's 3 meters. And that's to the left. Okay, so we got all those. We did it with number lines. The next step we're going to use is to use the equations. So remember that every time we use an equation, we rewrite it. It's a little bit annoying here at the beginning, but it will help us out as the year goes along. So where are we finishing? Well, if we look back at our example, we finished at the 8th meter and we started at the 5th meter. So it's going to be 8 meters minus 5 meters, and that gives us 3 meters. And notice that matches up here perfectly. And so it should match just fine. All right, moving along, do the next one. So we got delta x is equal to x final minus x initial. Where did we finish? We finished at the we finished at the 5th meter. And we started at the 8th meter. And now notice what we get. We get -3 meters. So what is the deal with the -3 meters? Up here, in the first one, it matched up. It was +3 and this was +3. Why is this one negative and this one positive? Well, you might be able to see this. If it's the left indicates that it's moving to the left. So, or the negative indicates that it's moving to the left. So it's going to be -3 meters. Now, what do you want? Do you want the negative or do you want the word left? Well, you can have either or. I wouldn't put both, but you can have either or. But when we do equations, we're definitely going to have the negative. So I would get in the habit of putting the negative on there because it's going to help you out in the end. Okay, here's the next one. So delta x is equal to final position minus initial position. We finished at the 0 minus the negative 3 meters. And we get positive 3 meters on that one, and that's what we get right here. If you mess up on this one, I think people just forget the 2 negatives. So one negative comes from the equation, and the other negative comes from the negative 3 that's in the question. Okay, the next one, we've got delta x is equal to final minus initial. We finished at the negative 6 minus the 8th meter, and that gives us negative 14. Look over here, this is positive 14, but because it's left, we'll make it negative. Okay, on the next one, we have delta x is equal to final minus initial. We finish at negative 1 minus beginning at the negative 3. So these two make a negative, or make a positive, so that becomes positive 2 meters. And that's what we get right up here, positive 2 meters. So it works. And if it doesn't work, you made a mistake. That's kind of a nice way of double checking to make sure you're doing them accurately. Where are we finishing? We're finishing at negative 7 meters minus the negative 4th meter. So it's negative 7 plus 4, which is going to be negative 3. And because it's left, that should be negative, and it makes perfect sense.